If the x-intercepts of y equal f of x are -7 and 1, what are the x-intercepts of y is equal to f of x plus 4? All right, so let's try to remember what's going to happen, for example, a here, to the function if you put a plus 4 inside the function. We talked about this in one of the earlier videos on transformations. Basically, by plugging a 4 into the function like that, a plus 4 in for the x value, you're actually going to move the graph 4 units to the left. So that means you're basically going to be subtracting 4 from each of these intercepts, and that's where they're going to occur. So it's basically going to be at -7 minus 4 and 1 minus 4. So that means you'll have -11 for the first answer and -3 for the second. And that's where the new intercepts will occur if you end up transforming the graph 4 units to the left, which is what's going to happen when you do x plus 4 instead of x in the function. All right, let's look at part B then. For part B, it says, what are the x-intercepts of y is equal to f of x minus 3? So using the same logic as the example above, we would say what? X minus 3, instead of plugging x into the function, is going to move the function 3 units to the right. Remember, it's the opposite of what the sign indicates in front of 3. So if it's a -3, we're going to move actually 3 units to the right. And that means we need to add 3 to each of these intercepts. So it'll be -7 plus 3 and 1 plus 3. So we'll end up having -4 and 4 as our new intercepts then. All right, let's look at case C then. For case C, it says, what would the intercepts be if we're dealing with y equals 2 times f of x? So this is actually important here, that you're not going to actually change the intercepts at all. Because remember, when x-intercepts occur, it occurs when y is equal to 0. So if y is equal to 0 and you have 0 is equal to 2 times f of x, right? It doesn't actually matter about this 2. If you divide both sides by 2 here, you still get 0 on the left. You still get 0 is equal to f of x. So basically we're asking at what x values do you get 0 for y? And essentially that's the same question before. So basically what we're saying here is that this is just 2 times f of x is a stretch. Remember, the function stays rooted though in its same location or same roots. In other words, its intercepts don't change when you stretch the function. So what that means is that basically we'll have no change here. We're just going to end up having -7 and 1, right? Because all we end up with when we solve this equation is the same statement that we would normally express for intercepts, right? At what x values is the y equal to 0? Well, we already know the answer to that. The x values where the y is equal to 0 are essentially -7 and 1. All right, so C was pretty easy. Let's go ahead and look at D then, the last one we need to learn. So for example D, we're basically saying, what are the x-intercepts for the function y is equal to f of -x? So what happens when you put a -x into the function instead of a positive x? Well, it basically reflects the graph across the y-axis, right? So it's going to switch everything across the y-axis. And that means it's going to be a mirror image of itself across the y-axis. What this is going to do is it's going to change the values of the intercept, right? Because it's going to sort of spin the function around across that y-axis. It's going to change the values to the opposite sign of what they were before. So this means you're going to end up with -1 instead of +1. And it means you're going to end up with +7 instead of the other way around. Now, if you think about this, you can kind of say, well, since -7 and 1 were our original x-intercepts, and as they were original x values where the y was equal to 0, just putting the -x in the function that we do in part D is going to basically be the same as putting a negative sign in front of each of those intercepts. And that's why we end up with -1 instead of +1, and we end up with -7, which is the same as +7. So that's why we end up with the 2 answers we do for example D.